Today I'll show you how to fix a lifted solder pad on an LED board. So what's the solder pad? Here we have a bare PCB. This surface is for LEDs. You can see that each LED pad has for soldering pads. If any of them came off, the LED won't light up, or may show a missing color. To fix it, we can use copper wire to reconnect. It's called a flying wire. Now, let's take a look at the repair tools. The soldering iron, electrical screwdriver, pointed tweezers, solder wire, and the key item, copper wire for flying wire repairs. The copper wire we use is approximately 0.1 millimeters in diameter. Don't be too thick or thin. And we'll also need some new LED chips and a testing box. Lifted solder pads are hard to spot, usually only found during repair process. To confirm the issue, carefully remove the faulty LED and inspect the solder pad underneath. See if the solder pad is missing. Look at this LED panel here. The mask has been removed already. You can see 2 LEDs are missing in this area. And one of the soldering pads has also come off. So the first step is to clean off the waterproof glue covering the repairing area. As this is an outdoor LED module, unlike the hard encapsulation glue we've used before, this module uses soft glue, which is much easier to remove. We can simply use tweezers to scrape it off, no heat gun needed. While you're doing this, make sure to clean off the glue not just around the faulty LED, also the glue around the bridging pin of the adjacent LED. As we will bridge them together then, just make sure the area is clean and ready for the next step. Alright, it's clean. Next, let's solder a new LED in place. And fix the lifted soldering pad using flying wire. Same steps as before. Turn on the soldering iron. Set it to 300 degrees centigrade and let it heat up. Okay, let's check if it's ready. Nice, the solder's melting fine, it's good to go. Now we need to clean up the solder pad on the board. Melt a little bit of solder onto it. This helps clean the pad and makes it smoother to work with. Be sure the pad has enough solder, but don't leave any excess. Then grab a new LED with tweezers. Keep the orientation the same as the other LEDs on the board. That means the dark corner with the notch should face the arrow on the board, or just match with the other LEDs. Fix one side of the new LED first. Then move to the other side. And press it gently with tweezers to keep it in place when soldering. After that, check for any solder bridging. If yes, just add a bit of fresh solder and clean it up again. Okay, next one. Oops, looks like I missed this one. Let me resolder it. Always double check your work. If the LED isn't soldered properly, it won't light up, or you might lose a color. Alright, that step's all done. Now let's fix the lifted solder pad by flying wires. Before that we should know how it works. For this P3 board, each column has 32 LEDs. Each driver IC controls 16 LEDs per column. Some IC model may control more, but here it's 16. So don't bridge beyond those 16 pins. Let me count from the bottom. 1 to 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Here, the 14th LED solder pad is gone. We can bridge it to the 15th LED pin with the copper wire, or we could go to the 13th one. Even the 12th LED pin would work too. The key is to pick the nearest one. Always follow the principle of proximity when bridging. But say if the 16th LED solder pad is gone, we can't go to the 17th LED pin, because that's beyond this IC's control range. Once that's clear, we need to understand the 4 pins on the LED, and what each one does. As you know, each LED has 4 pins, and each pin has a different function. See this LED here? Focus on the side with the dark corner. Its direction is aligned with the LEDs on this board. You'll notice a small notch at the top left corner. That's an important feature. This notch corner marks the positive pin, also known as the power pin, or the anode. Then, The bottom left is for red, bottom right is for green, and top right is for blue. This layout is what we call the RGB setup. So, when you're doing flying wire repairs, pay close attention to these color pins. If one of the RGB pin pads is gone, we can only bridge it up or down vertically. Avoid going left or right. But if the power pin plus pad is gone, we can only bridge it left or right horizontally. Avoid going up or down. Once you're clear on that, then you're ready to do it. On this LED board, the red color our solder pad at the bottom left is missing. We're using the copper wire to bridge it to the red pin just below or above it. It's pretty like soldering an LED. First, clean the broken pad with some solder. Then take out your copper wire. Since the copper wire is coated with insulation, so we'll need to scrape it off first. You can use the tip of the soldering iron to gently scrape off. Just 1 to 2 millimeters in length is enough. Or alternatively, a blade will work as well. Then place the copper wire next to the faulty pin. Solder it onto the LED leg where the solder pad is gone. You can use the flat edge of the soldering iron to help hold it in place. Then bridge the other end to the nearest red pin either above or below. Add a bit of solder to the iron tip to help secure the connection. Before soldering, be sure to scrape off the insulation at the other end of the copper wire, just enough to expose the metal. Make sure both ends of the copper wire have the coating scraped off, or it won't conduct and the LED won't light up. Okay, it's clean. Go ahead and bridge this end onto the red pin above. Also, double check that you're connecting to the correct red pin. Don't mix it up with the green or power pins. That part is super important. If the spot is hard to solder due to surface glue or poor contact, you can just remove the LED and replace a new one. To break the copper wire, avoid using a blade, as it may damage the board. Instead, just apply a bit of force, and gently wiggle the wire back and forth until it snaps off. This one here slipped because it wasn't soldered well. Let me fix that. It's also a good way to check if the connection is solid. Alright, the copper wire is off. Once you're done, make sure to tidy up the wires. Don't leave them messy. Try to keep everything clean and organized. Then just repeat the same steps for the next one. This one is also a red solder pad. Same steps as before. Start by scraping off the insulation coating on the copper wire. Then, solder it onto the red pin where the solder pad is missing. Next, bridge the other end of the wire to the red pin leg above. Before that, make sure to scrape off the coating on this end too. Be gentle. Too much force may break the wire. Also, double check that you're bridging to the correct red pin, either above or below. Don't mix it up with other color pin legs or the color output will be abnormal. Once we're done, tidy up the wire to keep things neat. Okay, we're all done. The new LEDs are also in place. Now let's do a quick test to make sure everything's working. When plugging in the connector, just like before, make sure the arrow direction next to the connector is same as the arrow on the board. Same goes if you're using a cabinet, the arrow direction on the module should face the cabinet handle. Alright, red looks good. Green, no issues. Blue, okay. And white, also shows properly. And as always we need to run a scan line check. That way, we can spot any wrong bridges or extra connections. For example, if the 16th pin got bridged to 17th pin, you'll see an obvious scan line issue. But here, everything looks normal, so the repair worked. Alright, let me power it off. Once all the repairs are done, we also need to apply waterproof sealant to the repair area. Since this is an outdoor LED module, we've already applied it here. But we need to wait about 1 hour for the sealant to fully dry. After that, we can reinstall the mask. Once the mask is back on, just put the LED module back into the cabinet, and it's ready to go.